Um, Greetings to you once again. This is welcome to our 5th session of the masterclass on research data analysis. Today we're going to be talking about non-parametric data analysis for comparative study on SPSS. You may wish to be reminded on the meaning of non-parametric data analysis. It simply means analysis that involve variables that are not normally distributed. In our last class, we talked about in a case where data analysis of a case where we have normal distribution of data after the normality testing. Now, if we assume that our data are not normally distributed and we concluded on carrying out our student t-test, however, it should not be continued because they are not normally distributed. However, we substitute student t-test in a case where we have abnormal distribution, where we don't have a normal distribution. So we substitute student t-test with Whitney U test. And we are going to be demonstrating it today in SPSS. Now, to demonstrate this, we are going to be assuming some data. Don't forget that student t-test is substituted with Whitney test, and student t-test is carried out when we have two comparison between two independent variables. Let's assume we have, from our coding, we have two groups. The first group are those who love Coke, drink, and the second group are those who love Fanta. And we want to measure the amount of glucose in their bloodstream. Don't forget that we don't need to code for glucose because glucose is the data we are going to get from glucose concentration is in milligram per dl and is continuous variable. And don't forget that we say that continuous variable are those variables that can have decimal number. Now, this will be in a scale because it's measurable. Why this will be in a category in no order. Groups will be in a category in no order, so we call it a nominal. Nominal are those categorical data in no order. Now, let's go back to our data view to insert our data. Now, under groups, if we should have 5 of them, group 1, we represent group 1. We represent group 1 with the first group, those who love Coke. Let's say there are 5 of them. Then we now represent group 2 with those who love Fanta. There are also 5 of them, making a total of 10. You can see it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, let me just assume the value for their blood glucose level after consuming Coke and after consuming Fanta. So let's say we have 3 milligram per dl, 4 milligram per dl, 4 milligram per dl, 5 milligram per dl, 4 milligram per dl. Okay, no, let me make it 4 milligram per dl, 6, 7, 13, 13, then 4. Why this will be, let's say 12, 3, 4, 7, 7. I'm just assuming it's a fictitious data, so we're just assuming it, and 3, for example. Now we want to check if there's any statistical difference between the group that love Coke or consumed Coke and those who consumed Fanta. Is there any statistical difference in the glucose level among those who consume Coke and those who consume Fanta. This is a typical student T test because of we are comparing two mean or two independent variable. Glucose is not dependent, group is not dependent on glucose. So we call the group independent. But glucose changes in group. You can see this is 13, even in the same group is not changing, but these numbers are changing. So that means this glucose dependent on this group, on group. So we call the group independent while the glucose is dependent. So now, since we have two categories, that's 1 and 2, Coke and Fanta, two independent variables. Two independent variables. Since we have two independent variables, and we want to compare the mean, so we are using student t-test. However, we cannot continue with student t-test because they are not equal. They are not normally distributed. In assumption, we are assuming they are not normally distributed. Now, how do we carry out the supplement or substitute for student t-test? The substitute for student t-test is Mann-Whitney-U test. Mann-Whitney-U test. You can see it in our slide. It's called Mann-Whitney-U test. Now let's see how it goes when we are using Mann-Whitney-U test. As usual, we go to our analysis. Then we go to non-parametric test. You know, we are dealing with non-parametric test. So we go to non-parametric test and we go to legacy dialog. Under our legacy dialog, we are going to choose two independent sample. I'll click on it. Now, it will bring this dialog box for us to choose what we are analyzing. As usual, our test variable, the variable we are testing is glucose. So we check in glucose, and the grouping variable, the group is the grouping variable. So we put it inside the box. However, we need to define this group exactly how we've coded it. And don't forget that group 1 is coded with 1, group 2 is coded with 2. However, some of you might have used 1 to code 0 and group 2, or maybe Fanta is coding 1 while Coke is coding 0. You have to insert it here that Coke as arranged on your spreadsheet, that Coke is 1 and the group is 2. You hit continue. After hitting continue, the next thing you go with is you hit OK. Now to bring out some group of data, where because our data is assumed, and I want to believe maybe because we have a very small data size, however, it's still enough for us to get a sample or analysis. Now, Mann-Whitney-U test does not calculate a mean. What it calculates, unlike t-test, it calculates mean rank. Now, our Coke rank, so it gives the differences in mean rank. You can see the mean rank for Coke is more than that of Fanta. Coke is 5.9, while that of Fanta is 5.1. Now, we now scroll down, the Z value is minus 0.24. However, we are going to look at the significance difference and to check for the P. We have to check the p-value, the one that states as is sig 2 tail is the p-value you have to check. And here it states 0.671, which is quite bigger than our assumed significance level, which is 0.05. So we have 67% p-value here, where we have a limit of, if you remember in our previous lessons, that we have a limit of 0.0 equals to or less than 5% of p-value. And since we have 67 or 0.67 p-value, then it is quite larger than 0.05, meaning that there is no significant difference. And when we state that there is no significant difference, that no is a negation, means we've accepted our null hypothesis, which states that there is no significant difference in glucose level of those who take Coke and those who take Fanta. So this is how to run Mann-Whitney test. Now we're going to go to the next one, which is the second non-parametric test that is used to substitute ANOVA this time around, and that is Kruskal-Wallis test. Kruskal-Wallis test is used in supplementary when you want to use a ANOVA test. That's when you have three independent variables. If you have three independent variables, unlike the t-test that has two, if you have three, it means you are going to be going for Kruskal-Wallis test, especially when it is not normally distributed. Now we're going to check how we run that on SPSS. Before we do that, we will need to edit our file, our spreadsheet, our data to suit the assumption for ANOVA, which is having to measure the mean between three independent variables. Now let's go back to our data. Yeah, this is what our data looks like. This is what our data looks like. Now, as usual, just like yesterday, we included those who drank water, who took water. That's let's include it here. What do you think will happen when I type water here? It won't accept it because I've not defined the group, so I need to come back here, edit. That's why it is flexible, like I said in the previous class. So that's why SPSS is flexible. So you just need to come and make an addition in the labeling of the value. So I want to include 3, which will mean those who love taking water. Okay. And we would now start by indicating we'll start by indicating what it means. 2, 3, 4, 5, making 15. So let me now include an assumed glucose level. Let's say 3, 4, 5, 8, 3. Yeah, so let's assume this is the value. Now, how do we now run? Now, how do you now run Kruskal-Wallis test? Kruskal-Wallis test is very easy. It's one of the easiest, and is a substitute or an alternative to one-way ANOVA. It's an alternative to one-way ANOVA. So this is how we run it. Analyze. Since the non-parametric data, we click on non-parametric. Then click on independent samples. Independent samples. Then we hit on customize. Then fields. Now, on this field, we are going to, as usual, our groups. We know where our groups will be. Our groups is going to be here, our defined groups. Why what we are measuring or the we are testing will come in here. Before we hit run, we have to click on the settings. Now, it is in automated tests based on the data. That means SPSS wants to run it for us automatically because of the nature of the data. However, we already know the kind of test we want to use, so we don't need that. So all we need to do is just to click on customize test. And we now click on Kuskawalis test ourselves. Then you leave this as pairwise because that's what we are going to be using to know the post hoc test, as in just like in ANOVA. So the next thing is we leave every other thing like that and now click on run. It's processing, you can see it. It's processing. Now we have our results. We have our results. Now, this type of test on SPSS is kind of even explanatory because the first thing we need to check is significance. You can see that it is really higher than the benchmark of 0.05. Now, since it is higher than 0.05, we are going to say that there is no association. There is no association. I repeat myself. Since it is higher than 0.05, like I've been saying earlier, then there is no association, or there is no difference between all the three groups. All three groups, there's really no difference between all three groups. However, the decision has already been made as well, or as a claim by SPSS that state that you should retain the null hypothesis. You can see that what we've been explaining so far in our class is totally correct. Even SPSS is saying that we should retain the null hypothesis. Now, the next thing to do is to know, had it been we had a significance one way in all the three groups, how do we now run the multiple comparison? How do we run the multiple comparison? Now, to run the multiple comparison or to check the multiple comparison, all you need to do is to click on this decision or click on the table here, double click. It will pop out this model view for us. You can see it. This is what is going to pop us and to give us a lot of information about what is going on. Now, because there is really no difference in this data statistically, it won't show us the multiple comparison. It says, you can see it's stating here that multiple comparison are not performed because the overall test does not show significant difference across sample. Now let's edit our sample to show a significant difference in a way that we are going to see how it really looks like when we have a statistical difference among the three groups. Now let's go back to our data. Let's go back to our sheets, our data set. Let's go back. Yes, this is it. Now, let me reduce that of water in a way that there's going to be significance. Like this should be 2, 1, 1, 0.5. It's just an imaginary number. So let's not. So let's see what happens this time around. And let me increase some of these values. Let me increase some of these values. Now, let's run it again. Let's run it again. Analyze. Then we come down to non-parametric methods and test. And don't forget that we are doing the Oscar Wallis test. So we click on it. On an independent sample, we click on independent sample. We needed to customize. So I click on customize. Then we click on field. Because we've done it before, so it's already there. You can see it. However, we can do it again. Groups will be in groups. Glucose will be in glucose. Then we'll just go to the setting and make it, customize it. We won't allow the computer to run it for us. and we now hit on the cross-call Wallis Hanover test, and we click on run. Now there's a significance. Now there's a significance difference. It's now telling us to what? To reject our null hypothesis. You can see there is the difference. Now there's a significance. Now where is the significance difference? Where is it one? Is it group 1 is different from group 2? Or group 1 is different from group 3? Or group 2 is different from group 3 and different from group 1? Like so on and so forth. So we are going to know now. So what we need to do, we double click on this table. Since it has given us a significance, you can see it, and it says we should reject our null hypothesis that states that there is no statistical difference between group 1, group 2, and group 3. However, we've seen that it is otherwise because it is greater than 0.05, and there's a significance. So it's a significant difference. So where is the difference occurring? Is it between 1 and 2, 1 and 3, or 2 and 3, or 2 and 1? Now let's check it. Now we're going to double click on this table. Now it brings us the model viewer. Now in the model viewer, we are going to get some other information such as the same significant difference. You can see it. It is 0.7. Then we now come down here on this Cook-Wallis test, cross-Wallis test. We now click on it. Then we click, make sure everything is like this. Then we now come here to click on the pairwise comparison. Under the view, we click on pairwise comparison. Now let's click on pairwise comparison. On this, let me repeat myself. On the drop down here, under view states independent sample t-test. Then we now click the drop down arrow. It brings a series of information, but we are interested in the pairwise comparison. We click on the pairwise comparison. Now it's bringing every information. The first information is that water and Coke. Is there any difference? Let's check. It is greater than 0.05. No, there is no statistical difference. Now, water and Fanta. Is there any difference? It states yes. That water has more glucose. Fanta has more glucose level than Fanta, and it's statistically different. So we now know in our research that those who consume Fanta does not have more glucose level than Coke. However, the same Fanta group has more glucose than water. So this is how to calculate Cook-Wallis test on SPSS. And I hope we practice more to be able to understand more. Our next information, our next statistical test we're going to be discussing in the next video is how to calculate chi-square test. And we're going to state the reason why we are going to be using chi-square test and how to calculate it on SPSS. Thank you very much. Stay tuned for watch out for the next video.